for this kind of invitation. Just waiting for the slides. So I'm going to go through a certain number of slides. I'll try to keep it as clear as possible. But I really wanted to share with you key elements of the research we've been carrying out for the last 4 years at IDDRI. So I'm picking from Paris, French think tank called IDDRI, and I'm leading a small team of 5 persons working on food system scenario, system of food system scenario. I'm just waiting for the slide to come and to be projected to you guys.
Okay, are you dealing with the slides in the room?
Yes, yeah. It's here.
Okay.
So, yeah, go to the next slide. So what's the context in which we are? Please go to the next slide. And each time I do like this with my finger, it's click. So the context in which we are is the one described by Norbert Linz at the beginning. Please click. We have a lot of concerns around the negative impact of the farm-to-fork and biodiversity strategy. Please click. And this is fueled by a lack of consistent evaluation and assessment that's been said by many of you. Please. And in this context, my presentation is around 4 main points. The first one, please click. It's time. The targets of the farm-to-fork are indeed ambitious, but I would really like to show how unavoidable they are if we are serious about the current environmental dynamics. Click. The impacts of the farm-to-fork and biodiversity strategies are, in fact, this is going to be my second point, way too systemic. Well, the strategies themselves are too systemic to be assessed by market equilibrium models only. That's what we said. That's what we show with the previous speakers. The third point is about the fact that biomass balance models that function on a different way show that the targets are indeed realistic. And the fourth point would be about the 3 policy levers toward which those biomass balance point. Next slide. So on the farm-to-fork and biodiversity strategies targets, we know that they really take a systemic approach to food system sustainability, including supply and demand side measures, plus specific references to trade, and I think Pascal already said that. And my point here is really to say that those targets, even though they are very ambitious, and even though to some extent, as shown by the previous speakers, might imply on the short term at least some decrease in the production, they are needed if we are to bring back the food system within planetary boundaries. And if you click there, I just want to take the nitrogen as an example. The target which is set is an absolute minimum of what needs to be achieved if we are really considering what's the situation. So targets are that we need to reduce the surpluses by 50% and the level of application by 20%. And if we look at the next slide, you see here the level of application of nitrogen all across Europe with an average of 145 kilograms of nitrogen per hectare per year. And on the map just next to the first one, you have another map which shows you by how much you should reduce nitrogen application if you want to protect surface water from degradation. And this goes well beyond the minus 20% at constant nitrogen use efficiency, which could, of course, increase in the future. But that shows you how ambitious we need to be if we are serious about our ecosystems. The next slide, please. So how to assess the impacts of the farm-to-fork and biodiversity strategy, which is basically the concern of today's discussion. We have basically 2 ways to do that: market equilibrium models and biomass balance models. Please click. So market equilibrium models, what do they do? Click. Basically, they reproduce the functioning of the current system, which enable them to assess the effect of a marginal change in that system, but which make it difficult for such models to apprehend the effect of systemic changes at the food system level. And I just give you an example here when the GRC tried in 2019 to assess the effect of an ambitious shift in diets, the models, Aglin Cosimo, was not able to produce sensical results. And then the other option is to have biomass balance models, where you have no prices, but only physical rules, just to make sure that the assumptions you make do not violate the rules of the physics, if I may. And those models are really robust when it comes to apprehending the environmental issues. Next. So in the case of the farm-to-fork assessment, the two previous speakers made very interesting points using market-based model, market equilibrium models, be it partial or general equilibrium model. Click. But what they were not able to model, and they explained that, was no change or only limited change for the GRC study in the EU demand. Click. Limited to no innovation in the EU supply, and most importantly, a business as usual, assuming that yields can still increase significantly in the next 5, 10, or 15 years. Click. While the situation is the one you can see on that slide, which is basically that yields have been plateauing over the last 20 years in most European countries, even though we still have margins of maneuver in Eastern Europe countries, partly because of the fact that agro-ecosystems are totally exhausted, and in particular soils. If you go to the next slide, you see an analysis provided by colleagues in Science in 2019 showing how landscape simplification on the left-hand side of the screen in fact alter the provision of ecosystem services like pollination and in turn negatively affect production. Yet landscape simplification is what has been happening in Europe over the last 15 years. The next slide, please. And the last point, in particular for the USDA analysis, is that the same targets than the one adopted for Europe are applied for the rest of the world in terms of reduction in inputs, while contexts are so different, and the next slide shows that, in the sense that in many countries in the world, so this is in green are the areas where we are very close to the maximum organic potential, and in orange or red are the areas where we are very far away from the maximum potential, in particular because we lack inputs and because farmers do not have access to them. So it doesn't really make sense to say, oh, well, we're going to limit or reduce by 20% access to nitrogen to African farmers, right? So the next slide. There is an urgent need to take the results with caution, even though it's really important to have those first analyses. We also need to complement those analyses with biomass balance model, which is what I'm proposing. Next slide, please. So the 10 years for agriculture scenario is a scenario we put in the debate 3 years ago with IDDRI, click, whereby, well, it's basically a future study, a classical foresight analysis, click, where we model the European food system functioning using a biomass balance model, as explained earlier, click, and where we make a set of very radical assumptions, not to say this is what we need to do, but rather to open up the discussion space. And the assumptions we made on different compartments of the food system are pretty much aligned with the farm-to-fork targets, click, on fertility management and nitrogen cycle closing and phase out of synthetic nitrogen, click, phase out of pesticides, then 10% landscape features, resilient livestock system favoring low biomass opportunity cost system for land use, biodiversity and climate purposes, and last but not least, healthy and balanced diets. The results are very interesting and important in today's debate because the changes in diets, the changes in feeding strategies, and the changes and the increases in nitrogen use efficiency basically outweigh the impact of production reduction, making the European Union a net exporter of calories by 2050 under that scenario, while today it is basically a net importer of calories because of the massive amounts of soybean the European Union is importing to feed a growing livestock. So I'm not going to go through the whole next slide, if you can go through, but it shows you the full scenario. So we started with diets, click, then parameterized farming systems, click, on the vegetable production, then livestock production, if you can click 1, 2, 3 times. again. So that's basically a scenario, click again please, where you have, where you can reduce significantly nitrogen losses to the environment, where you can reduce greenhouse gases emission by more than 45%, click again, where you have biodiversity recovery in most agro-ecosystems, click. Again, the doctor is very happy. And then again, you can click. And the last point is the most important one. Not that one. Again, then you maintain the export. And that one is the most important. What does this graph show you? It shows you basically based on a state database, the current situation, which is the gray bar on the left-hand side of the graph, which is basically that as of today, the European Union imports net 11% of the calories it consumes. And the pink and the blue bars are the situation, are the bars showing the situation in which we have the assumptions of the STIFA scenario, whereby the European Union basically becomes a net exporter of calories by 12%. And the brown bar is a situation in which, as hypothesized by the USDA and Wageningen study, you have change in supply, but not in the demand. And then you can see, of course, that the level of import greatly increases. And Pascal, I can see I need to finish, right? Okay.
Yes,
so
well
okay, so I have, you can go through those slides, click 3 times. So just to show you that it's very coherent to many of the scenarios, in particular on the demand side. And so you can see that the demand policies are key, in particular in accordance with what the IPCC tells us, and that, of course, it has to do with how much vegetable production is used for animal feed. And of course, as was said earlier, we have a lot to do in terms of trade and in terms of maintaining a sustainable competitiveness for the European Union. And thank you so much for your attention.
Thank you very much.